Hey y'all, it's your math teacher, Mr. Boyden, back at it again today. Here we are in lesson 2, and we're going to talk about measures of central tendency and dispersion. So let's start out with something pretty easy. I'm going to guess that most of you watching this video are already pretty familiar with concepts like how to find the mean of a data set. So like if I give you a list of numbers and ask you to find the mean, how would you do it? You'd probably know that you need to add up all the numbers, and then you need to divide by how many numbers there are. What about the median? Usually when I ask this in class, people say the middle number, the middle number. That's true, but you got to make sure you put them in order first, okay? What about the mode? That's the one that occurs most frequently. And we teach that a lot like in Common Core stuff, or we teach that a lot at the lower levels. When you get into higher level stats, it's not real common, although it's something we're going to just make sure you know. It's the most frequently occurring number. The range, I'm actually going to write that one out. That's the maximum value minus the minimum value. Whoops, minimum value. And then we also have the interquartile range. We're going to get to that a little bit later, and then standard deviation. Let's go back to the title of the lesson for just a second. Measures of central tendency and dispersion. And here's the deal, guys. If I give you a list of numbers, when you talk about where the center of the data are, or the center of that list, it's really hard to describe that, actually. We have multiple ways of doing it. Mean is one way. Median is another way of doing it, and they're different. So when you say, well, where is the center then? Well, these are two different ways of measuring it because it's really hard to put our finger down on. And then dispersion, all that's talking about is like how dispersed are the data, as in like how spread out are the data. And we have a couple different ways of measuring that, and that's these three right here. Okay, so range, interquartile range, and standard deviation all give us information about how spread out a data set are, like how far apart are the maximum minimum values. We'll talk about these in just a minute. So these first two are measures of central tendency. What about mode? Is mode a measure of central tendency? Guys, it's a little debatable. A lot of textbooks are going to say yes. I say no, and here's why. Consider an example where you had a bunch of students who were absent and didn't take a test, and so the scores are like 0, 0, 0, 0, 0, 0, 42%, 89%, 95%. Well, what the mode of this would tell us is that the most common thing is 0. And then, but you look, and students who took it on average are passing. So the mode is 0, but the average student is passing. That's very confusing. So I really don't like mode, and there's a lot of other examples we could come up with where mode kind of leads you to some weird conclusions. It's one of those things that doesn't come up a lot, actually, and you don't get tested on it very much at this level, but it's something we are supposed to talk about. So speaking of things we're supposed to talk about, let's talk about this formula right here. This is for the mean. And we already said that the mean is found when you take all the numbers in a data set and you divide by how many there are. Well, let's break down the symbols. First of all, let's talk about this one. This is pronounced X bar, because it's an X with a bar over the top of it. And then what does all this stuff over here say? Well, remember that this right here is a sum, it's a sigma, and it's saying that we need to add up all the X values. Well, in this case, it's not like plotting points X and Y, it's just like literally numbers in the list. So what this is saying right here is add up all the numbers in the list, then right here, N is the number of terms, or number of data points. And so this is equivalent to adding up all the terms and dividing by the number there are. Okay, so I bring this up here because sometimes people get really confused about like, oh, it's a big formula. Don't worry about it. It's all good. Just read it. Okay, break it down into symbols. You'll be all right. Now, we also need to talk about standard deviation. Standard deviation is another and honestly a lot more accepted way of describing how spread out a set of data are. And so let's break down this formula a little bit. Over here on the left, it's the same thing as the mean. So that's dividing by the number of terms, or number of data points. What is this? Well, X bar, we just defined that. That's the mean. So what this is telling us to do, oh, and here is each data point, or each value in the set. So this is telling us to take each value, subtract from it the mean, square that result, add all those results together, divide it by the number of terms, and then take a square root. Now guys, that's a lot of steps, okay? It's a lot of work. We're going to see in a minute that the calculator is usually going to be able to do all of that work for us, and so that's a good thing. We want to let the calculator do that when possible. Or if you go on in science or math, there'll be times where you're going to use Microsoft Excel or Sheets or whatever the Apple product is as well. So also down here we have the variance, and you know what? I totally glossed over this symbol right here, guys. That is also a sigma. And the reason they use sigma is because it starts with an S and standard deviation starts with an S. And you say, but wait a minute, I thought this was sigma up here and I thought that was sigma in here. Yep, totally. That's a capital sigma in there. This is a lowercase sigma out here. So please be mindful of that. Also, standard deviation is very closely linked to variance, as in it's the same thing if you didn't write the square root over the top. So we're going to denote that as sigma squared for the variance. I want to show you really quickly visually what it does, and then we're never going to do it by hand again. We're going to use the calculator. Let's take a look at this very basic data set. And I'm going to make a number line, 3, 4, 5, 6, 7, 8, 9. Now guys, again, you're never going to do it this way, okay? This is not how you would calculate, but what I want to do is I want to show you what some of the features are of it and what makes this number big and what makes it small, and if it could be negative, and all those things will be addressed here. So what would we need to know? We need to know how many terms there are. 1, 2, 3, 4. There's 4 terms. That's easy. We need to know what the data values are. 3, 4, or 3, 5, 7, 9. Got it. We need to know x bar, the mean. Guys, if you want to type it in and figure it out, you can. I'm going to give it to you, though. It's 6, just to save time. Okay, and that's all we need. So now we're going to evaluate this formula for each of those values. So I'm going to plug in first, just left to right, plug in a 3. And when I plug in a 3, I get right here that that would be a 3 minus the mean, which is 6. And it has to be squared, so that would be negative 3 squared. Let's look at that visually. We already know that the mean, oops, except I missed. We already know the mean is right here, and that's x bar. And so this negative 3 is saying go 3 to the left. Left 1, 2, 3. And you know what? That's where 3 is at, so that's perfect. Now, squared. It says literally take this length and make a square out of it and tell us its area. Now, y'all, we know that 3 squared, or negative 3 squared, is 9, and the area of this square, because it's 3 by 3, is also 9. Let's do the same thing for 5 now. For 5, it's the same deal. That would be 5 minus 6 in here. So we go 1 to the left, which is where 5 is. So the visual matches the math. And it says build a square right there. That's a 1 by 1 square, so its area is 1. What about 7? We go from the mean, so it's all relative to the mean, from the mean to 7. That's a distance of 1. Build a square. Its area is 1. And then we're going to do the same thing for 9. So for 9, that'd be like 9 minus 6, which is equivalent to going 3 to the right. Build a square, and that square, and I know my drawing's not any good, guys, please be nice about it. It's still a square with area of 9, okay? So, what does this then say to do? We've just done this part of the formula. It says to add all those together. Okay, let's add all those together. So that 9 plus 1 plus 1 is 20, and then divide by n, which is 4. And you know what? Let's do variance, just so you can see variance, because this is not very square rootable. So that would be 5, although from this, we could see that if you did do the square root, it would just say root 5. So we have the standard deviation here on the right. We have the variance there on the left. So let's understand some of the key features of that. First of all, it can never be negative, because notice, no matter what we get in this calculation, we square it and it becomes positive. These all have positive areas. The reason they do that is if we had let these be negative, everything would have canceled out. And we would have gotten 0 as our answer, because we'd have had 2 positives and 2 negatives of the same size. And that would have said our data were not spread out at all. So the way we interpret the value of this is the bigger the number, the more spread out the data are. The smaller the number, the more compact or the more condensed they are all together, and we have fewer outliers and things of that magnitude or that nature. Okay, so that's really what I want you to see out of this. Let me get those negatives off of there so they're not in the way anymore. Okay, the other thing is, notice 7 is only 1 unit away from 6. And the way it impacts the standard deviation is by adding a 1. But if you go to something that's 3 times further away, like 6 to 9 is a distance of 3, it has a 9 times greater impact on this. So the way this is weighted, this formula, is numbers that are further away really blow up the values. Okay, so those are just important features to understand. How do we interpret this? It's all relative. So we compare it to some other data set and we'd say, oh, this one's more spread out, this one's less spread out. That's what it's useful for. All right, now that we have a solid understanding of these main statistics, now I want to show you how to use the calculator to find them easily. You probably want to take a minute, write down these values in your notebook so you have them, and then if you have a TI Inspire calculator, that's what I'm going to use for the demo today. If you don't, then just Google how to find one variable statistics. And I'll write that down. So 1 variable statistics for your calculator. Because pretty much any graphing calculator will do this, but I only have this one to show you today. Okay, so let's take a look. If you're using the TI Inspire, here's how it's going to go. You're going to want to open a new document. And in that document, you're going to want lists and spreadsheets. This gets confusing. A lot of people think it's data and statistics because we're putting in data and doing statistics, but that's actually for visual work. So this one, it kind of looks like an Excel icon there. So go ahead and click into it. The first thing we have to do is we need to name our data set. So I'm going to call mine data, just because I don't have a context for it. And then I'm going to come down in cell A1 and we're going to start typing in the numbers. Now, when you do this, you're just going to hit like 8 and then enter, and then 2 and then enter, and you're going to notice that as you do that, it automatically fills in vertically, which is what we need to do. The Inspire is programmed to work really, really well vertically, just like the older TI calculators. They also work in a list that goes vertically. So I'm going to type these in real quick. And then from here, I'm going to come back up to the top of the page, and I'm going to do my calculation right in this page. There are other ways to do it, but I like this one the best. It's really quick and easy. So all I'm going to do is I'm going to go to the menu, and I'm going to look at my statistics and see what's in stat calculations. And it turns out that I have one variable statistics right there. So yeah, they default to one list, and I only input one list, so that's perfect. And then here, I'm going to have the option to pick my list name. Now, all you have to do is either hit like the right arrow on some of the calculators, or if you have an older version of the software, it might be the down arrow. But in there, I have data as an option. So I'm going to click on data. And for this type of calculation, you actually don't need to change anything else. Okay, this is perfectly fine. So then I'll hit OK, and boom, there it's done. They did the work for me. So that's a lot quicker than needing to calculate this stuff by hand, because now I can just look through and pick off the values I need. We were asked for the mean. X bar is the mean. So the mean is 4.4. What is this? Sigma x. That means it's added all the numbers together. The total of all the numbers is 44. Here they squared them and added them together. This one is the sample standard deviation, which if you ever take AP statistics or statistics in college, you're going to end up using that a bit. IB, if you're in my IB course, then we're looking at this one right here. And this is the standard deviation with the sigma that we learned previously. So 3.14 is what that looks like, that rounds to. And then what is this? N is 10. That's the total number of numbers in the list. That makes sense. That's what we typed in. The smallest value is 0. The first quartile value, which we'll learn more about in a second when we get to box and whisker plots, that's 2. The median is 3.5. Quartile 3, which we'll learn about in a minute, is 8. And the biggest number in the list was 9. Okay, so that's the information it gives you, and that's a real easy process. So you can refer back to this video tutorial anytime that you're, like if you're studying for a quiz, studying for a test, having trouble analyzing some data. Hopefully this little walkthrough will be a helpful thing for you. This brings us to the box and whisker plot, which is one way of representing data visually. It's actually technically a graph. It's a way of graphing data. So let's consider the things that we can learn from these data, or from this visual. So I'm looking at the box and whisker plot, and down on the bottom here we have numbers from 0 to 100. Just to give it a context, let's say that these are test scores expressed as a percentage. Okay, so let's take a look at the box and whisker plot and see what we can tell. Are you able to say what the largest value is in the data set? Sure you are. The upper extreme is also known as the maximum. That's what we saw in the calculator just a minute ago. So the highest data value in this is 100. What about the lowest score? What's the worst test score somebody got? They got down here, it looks like that's about 18. Now guys, if your eyes see it as 17 or something, that's fine. I'm going to say that 18 is the lowest, because the lower extreme is also known as the minimum value. Okay, the box plot will always show the median. Please make sure you know that's the median. It's not the mean. Now, okay, it might coincidentally be that the mean and the median are the same, but this is always defined in a box and whisker plot as the median value. Okay, the lower quartile means this. It's no different than on a graph, how we break the Cartesian plane into 1, 2, 3, 4 quadrants. What we're doing here is we're breaking a data set into 4 chunks. That's why it's a quartile, okay? It's out of 4. So what that tells us is that 25% of the data that generated this graph are from 18 to maybe 51. And 25% of the data live in the box on the left side, and 25% of the data live over here, and 25% live over here. Now, something that gets confusing for people is say, wait a minute, this whisker over here is a lot longer than this whisker, so maybe a lot more people got these scores because it's longer. That's not what it's saying. What it's saying is the bottom 25% is a little bit more spread out, at least in terms of its range, than this upper 25%, this upper quartile. Now, the lower quartile, or this value right here, is often referred to as Q1, okay? Because they call it like the first quartile score. And this one up here is normally referred to as Q3. And that means that actually technically the median, and we don't call it this because median's more descriptive, but that's technically Q2, and the upper one is technically Q4. So for each of these 4 regions, we're taking the value at the high end and we're calling that the quartile value for it. And that leads us to the interquartile range, because all we do to get that is we take the Q3 value minus the Q1 value. Let's actually do the calculation here. The Q1 value, I'm just going to dot that down. To my eyes, that looks like that's maybe 87. And then I'm going to come down here, and that looks like that's maybe 52, so minus 52, and I get 35. And you say, well, why would we want that? Well, guys, here's why. Because let's say you were going to look at a data set of like household income in the state of Washington. And so there are going to be some households that make no money, and you want to look at the range. Well, a problem that we have is that Bill Gates calls this state home. And so you're going to have a range from like 0 to 100,000 million billion. So then you get some stat like, the range of income distribution is over $1 million. That's not really very descriptive because there aren't very many people up here. This guy, Mr. Gates, is an outlier in that set. So if you break this into quartiles, maybe quartile 1 is 18,000, and maybe quartile, the upper quartile is, I don't know, 106,000 maybe. Okay, then you get this range between those two, and that gives you a much better idea because it's not skewed out by outliers. So the range is very susceptible to being blown up by outliers, but the interquartile range is not because it's not going to take those values out at the end. Now that leads us to something else called a percentile score. And this comes up a lot, particularly for you. You've probably seen it on your PSAT score. And if you still have your PSAT scoring booklet and you want to go look at it, this might help you understand what it's saying a little bit more. So what a percentile does is it tells you what percentage that you are higher than. So for example, if you get your PSAT back and you get first percentile, what that tells us is that you beat 1% of testers. Of course, that means you failed to beat 98% of testers. So guys, that's not good. First percentile in a test score in school is not a good thing. What you really, really want is you want the 99th percentile, because that means you beat 99% of testers. And that means you did really, really well. 99 percentile is actually as high as you can get. You can't get 100 because if you got 100th percentile, that means you'd have to have beaten yourself, and that's not possible. So 99 is the upper end of this. Now, bigger is not always better. Like, let's say we were talking about your cholesterol levels. And you go to the doctor, and they say, hey, you have a 98th percentile score. And you go, wow, that's really good. I learned in my stats class from Mr. Boyden that 99% is as high as it goes, and 98% is almost to the top. I got a new high score. Hey guys, it might not be a good thing to have a really high score on your cholesterol, possibly. I mean, I'm not a medical doctor, but you'd want to be really careful. Or like another classic example is blood pressure. So you go, you go into the clinic and you have a 99th percentile blood pressure. You go, woohoo, hot dog, I'm winning. No, you're not. That's super, super dangerous. You don't want that. So please be aware that you have to be careful in the context when you read these scores, because bigger is not always better, lesser is not always worse. You just have to be careful. Let's look at an example with some questions. This would be a good opportunity for you to pause the video, try it on your own, and let's see what you understand about box and whisker plots at this point. So here we go. How many people were polled in the survey? We actually have no idea. Like, literally none. Okay, we're talking about hourly wage of college graduates, so I mean, there have to be at least 4 or 5 people that were polled in order to generate this box and whisker plot, but it could have been 1 million people. I have no idea. That's one of the weaknesses of these. What about the median? Can we get that? Well, the median is always this guy, so this is, I don't know, about halfway in between 24 and 26, so I can't tell exactly, but I can tell it's about $25. The mean wage, I actually can't tell the mean. Okay, I don't have a way of knowing. I'm suspecting that it's in the neighborhood of 25, maybe a little bit bigger than 25. If you take AP stats, we'll talk about why. But we don't really know. So I actually am not going to even put a number down. I'm just going to put don't know. That's another potential weakness of the box and whisker plot. What about Tom? Tom's in the 40th percentile. What is his hourly wage? Again, this is a question that we can't answer exactly, but we can give a range, because if 25% of the data are here and 25% are here, by the time we get up to this 25, we've already accounted for half the people. Well, he's above 40% of the people. So what I know is that the 40th percentile is somewhere inside this box. And it's probably 24 or higher, but we don't actually know. So guys, I'm going to actually leave this blank because we don't really know. We know that it's at least like 23, maybe if that's 2380. It's between 2380 and 25 somewhere, but we're not able to nail it down. So that we have information about it, but we don't have the answer. And then what percentage of all the people that were polled are in the interquartile range? Guys, by definition of the interquartile range, it's taking the people in the box, and so, or the boxes. So what that would mean is that that's a grand total of 50%. That does not depend on the context. That's always true for this type of representation. Another representation that we need to understand is frequency tables. This is another way of representing data. It's a little more concise than a long list. So let's try to answer some questions. The following is the age of the students that are in my algebra class. Full disclosure, guys, I've made these numbers up. I can't actually give out the ages of my students, but you can imagine an example like this, okay? So let's try to answer the questions as given. So with the ages that are the students are 14, 15, 16, and 17. No 13 or 18-year-olds in algebra this year. And we have 9 14-year-olds, 12 15-year-olds, 6 of them are 16, and we have one person who's 17. So how many students are in the class? Well, that's pretty easy. We just add up all the frequencies. That's all the people. So let's add those up. So let's see, 9 plus 1 is 10, plus 12 is 22, plus 6 is 28. 28 students in a class. If you randomly picked a student from the class, what's the probability that they are old enough to have a driver's license? Well, the year is 2019. I guess I just dated the video. But in 2019, you have to be 16 or older to get a driver's license. And so how many students could do that? There's 6 plus 1, that's 7 out of the 28 students. And so we can simplify that down. That probability is 1/4. Now we get to find the mean, median, mode, range, and interquartile range. Let's see how useful the calculator can be in order to do that. So I'm going to pull up my calculator again, and I'm just going to get a brand new document here. So home, new document, don't need to save the old one, and then let's add a list and spreadsheet, and then I'm going to type in these data exactly as they were written. So what we had is that we had a person who was 14, 15, 16, and 17, and then we had 9, 12, 6, and 1 in the other list. 9, 12, 6, 1, and then I need to go back up to the top and name these. So on the left, those numbers were age. And on the right, those are the frequency. So I'm just going to call that FRE instead of writing out the whole word. And then I'm going to come over here just like we did last time, and I'm going to go to one variable statistics again, because really I'm looking for the same types of statistics. I just have a different little bit of information here. So how many lists do I have? A lot of people get this wrong, guys. A lot of people are going to select 2. That's not right, because what this is really asking you is how many variables do you have? Frequency is not a variable. It's a descriptor of how many people have the age, but it's not its own variable. So we're going to leave that alone. And then in here, we're going to use age as our our X1 list, and then we're going to use FRE as frequency. I put it that way on purpose. And we're going to hit OK, and we're going to see what we get. So what were we asked for? We were asked for the mean. That's 14.96. So I'm going to go fill that in. So 14.96. We can find the median in here. So median is 15. So I'll go write that down. So median is 15. And you know what? I'm going to record the rest of these. So we had, I want Q1 and I want Q3 as well to get my IQR. And then min and max, or the range should be easy. So let's go get Q1 and Q3. So Q1 is 14 and Q3 is 15.5. 14 and 15.5. All right, and let's try to answer these questions now. The interquartile range is Q3 minus Q1, so 15.5 minus 1 or 14 is 1.5. The actual range is the biggest minus the smallest, that's 17 minus 14. So that's 3. It's a coincidence that's half of that, by the way. And the mode, I think we can answer without doing any extra work at all. The mode is the most frequently occurring one, highest frequency. So that's going to be 15 years old. Now, some people write 12. They go, wait, 12 is the biggest number, though. But 12 is describing that 15 happens 12 times, so be careful. So now we need to make a type of graph to display the data. And the question is, what type would be the best type at displaying this? There are 2 that come to mind for me in the moment. One of them would be a frequency histogram. So let's do that. That would look like this, where on the bottom we would have the age. So 14 is one of the ages, 15 is an age, 16 is an age, and 17 is an age. So we'll label that as age, and that would be frequency over here. And then we just put a bar for each of those. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 1, 2, 3, 4, 5, and then 10. And so we can make bars on this. So that would be 9 up here. All right, so there's our first one. And then 15 goes up to 12. Whoops, sorry, not easy to draw on this thing. And then 16 only goes up to 6. And then 17 only goes to 1. So this is an easy way of showing the distribution, okay? So we can see that more of the data are on the left. We can see that 17 is real low, and that does that nicely. Now, I also want to practice doing a box and whisker plot here because we haven't made one yet. We've just looked at them, so let's make one of our own to practice. A box and whisker plot always needs to have an x-axis on the bottom, and a lot of people forget to do this. So guys, please be careful. If you don't have an axis label on the bottom, it doesn't mean anything. Like, it's just a picture of a box. So you gotta have this. Just like you would always know you need to put labels on here, this is also a graph. So 14, 15, 16, and 17. So we know that the minimum value is 14 and the maximum value is 17. We know that the median is 15. And then, oops, I got rid of Q1 and Q3. I better go back and get those real quick. So excuse me just a second because I realize I just deleted them. So 14 and 15.5. So 14 and 15.5. Now, something interesting just happened because this number right here is both the minimum and Q1. So how do we draw that? Here's what we do. You have to have a box. So let's draw the box, and the box has the median in the middle there, and it's not like dead center, but you can see there's a little bit of skewness here. It's not centered. And then we have a whisker going out here, and then what happens on this side over here, because the minimum value and Q1 are the same, it doesn't have a whisker on that side. So again, this graph shows that most of the data is concentrated on the left, and this also shows that most of the data are concentrated on the left. Final thing we're going to look at today is called cumulative frequency. Very similar to frequency, and I think you'll find it very intuitive, so let's get going on it. So what we're going to do, we have some data set here. This is actually from test scores from a few years ago, I think. We're going to complete a table, draw a graph, and a frequency histogram, and we're going to see what we can find from the visuals. So guys, here's all it is. We're going to figure out how many scores range from 0 to 50. And so I'm just going to cross them off as I go. So I got 1, 2, 3. And then we're going to find how many scores go from 51 to 80. So from 51 to 80, oh, I missed one right here. Whoops. So that's actually a 4. Are there any from 51 to 80? No, the frequency is 0. 81 to 100. Are there any scores from 81 to 100? I'm looking for 2-digit numbers, and I'm not seeing them. 101 to 130. So 101 to 130. So I'm going to have 1, 2, 3, 4, 5, 6, 7. How many scores from 131 to 150? So 1, 2, 2. And then I guess the rest of them are 151 or greater. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay? So, and maybe these are like scoring bands for an IB assessment or something. So all cumulative frequency is, well, I'll tell you what, I'm going to write it and you can see if you figure out how I get it. So that'd be 4, 0, 0, 11, 13, 25. So all I'm doing is I'm going down the table, and every time that there's something added to the frequency, I add it on. So like 4 is 4, 4 plus 0 is 0, or excuse me, haha, I made a mistake. This is 4 and 4, sorry. So 4 plus 0 is 4, plus 0 is 4, plus 7 is 11, plus 2 is 13, plus 12 is 25. So that's the cumulative frequency, and that allows us to make a cumulative frequency graph. I'm gonna label my x-axis by 20, so 20, 40, 60, 80, 100, 120, 140, 160, and 180, 200. And then vertically, we need to make sure we fit in everything up to 25. So I think this is only, what, 14 tall? So I think I can go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, and then 25 will be right there. So this is our frequency, and down here is the score itself. So now all we're going to do is we're just going to plot the points. So the cumulative frequency, the first one is 4, and that goes for a score of 50. So, and I guess I'm going to use the right end of the interval just like we did with box plots with the quartiles. So I'm going to go to 50. 50 is right in here, go up to 4. There's our point. Now we are going to start down here with nobody got a 0. Okay, so nobody got a 0. By the time we get to a score of 50, 4 people have achieved in that range. The next one we're going to go to 80, and that's still going to be 4. And then we're going to go to 100, and that's still going to be 4. And then we're going to go to 130, but now we're up to 11. So 130, and we're already up to 11. I'm going to go to 150, and I'm going to be at 13 now. So 150, and we're now at 13. And then if we go to 151 plus, we get 25. So what I'm going to do is I'm going to pick the actual highest score, and I'm going to use that as the end range of the plus. So I see a 179 here, I see a 180, I see a 180. It looks like a top score was 180. So I'm going to make this, I'm going to make a little modification here to 180, and so then at 180, I have everybody. So I'm up at 25. And then what we try to do, and just fair warning, this is not going to look right, but we're going to try to sketch a smooth curve that hits all those points. Okay, and so something like that. So that's a graph. So now we can see, okay, like, and if I wanted to know the median, for example, so what were the questions we were asked? Can you find the mean, median, mode, interquartile range, range of standard deviation, and a percentile? We can find a lot of those actually. So think about it like this. This graph is telling us right now there's 25 people. So if there's 25 people, then which person is the median person? So if you divide that, what you could think about it is like if you had 12 people on the left of a number and 12 people on the right of a number and 1 in the middle, working our way to the middle, that would be the 13th person. So to find or to estimate the median, if all you had was a graph, you'd go to 13, you'd go over until you hit the graph, and then you'd work your way down. And so you'd say, based on this graph, it appears the median is at about 120, 140 is 150. You do the exact same thing for the quartiles. For the quartiles, you'd figure out where is the Q1 person. So we have this right here in the middle. So where is the Q1? I might do like 25 divided by 4. And 25 divided by 4, that comes out to be 6.25. So it's about the 6th person. It's not super accurate, but I can come over like this and I say, okay, the 6th person is there. So what is this? And on this graph, it's really hard to get a really good reading because the numbers are so big and my graph is so small. But maybe that's 115. So I'm just doing an estimate here. What about quartile 3? So that was 6.25. I'd multiply that by 3 to get quartile 3, and I'm going to round it just for ease of access. So let's say that that's the quartile 1 value is the 6.25th person, which means that the 18.75th person, which is not a real person, I get that, I'm being sort of facetious here, the 18.75th person, or the 19th person, is the Q3 person. So let's go to that person, so 19, and that person is here, dot that down, that's about there. So that's like maybe 185. So yeah, we can find the interquartile range. We can find the range, well, kind of, except this says it goes to 0, so that's not quite right. So it's really hard to find the range. The mean, I have no way of finding that. Okay, I have no information about that. The mode, I actually can't tell that by the graph because it's not telling me how many individual values there are. It's telling me, like, if all I have is the table in the graph, I know how many numbers are in a range, but that doesn't tell me how frequently each individual value occurs. So I can't do that. And what about 70th percentile? So a 70th percentile would mean that you beat, so let's do the percentile up here. So 70th. The 70th percentile would mean that you beat 70% of the people. So we need to figure out how many people is 75% of the people, so, or 7%, or 70, excuse me. So that's 0.7 times 25. So that's 17.5. And if you beat that many people, that means you are the 18th person. So we're going to go up to 18. go over, go down, and we're at like, I mean 182 maybe. So its 70th percentile score is maybe 182. Now, the more detail you have on a graph, the easier it is to have that precision. I don't have a ton here because I made it myself. So let's look at another example where we'll have a little bit more precision and it will be a little bit easier. Here's another example. I encourage you to pause the video, try this one on your own, and then see how you do. We're talking about the number of points or the number of marks scored on an exam. So let's try to answer these questions based on what we see. By the way, please pay no attention to this dotted line. It's just illustrating something because I took this off an online resource. So don't worry about that dotted line. That was some teacher trying to demonstrate something to their class. So let's try to answer the questions. How many students took the exam? Is that something we can tell? Yeah, sure it is. They tell us the cumulative frequency goes all the way up to 70. That tells us that 70 students took the exam, so that we can know. What about the mean and median of the scores? Are we able to say that? Well, if 70 students took this, the middle student is like the 35th and 36th student. So 35th or 36th student, so the average of those two. So we can go in here to like 35, and we can trace this over, and this goes right down into here. So no, we can't say the exact value of the median, but we can approximate it really well. If I'm going to here and down, then I'd say this is probably, well, it's like 42.5. Since it's 35th, 36, I'm just going to round up. I'm going to call that 43 for the median. Now, it might be off by 1 or 2, and that's okay because that's not a true data point. That's a line connecting them. It's a projection, but we can get right in the ballpark. The mean, no, I don't have a way of doing that. What about the interquartile range? So again, we have 70 students, which means we can break them up into groups of 35 and 35. And guys, that's why I needed to take two numbers here. So 35 and 35, that breaks into two groups. But if I'm doing interquartile range, I need quartiles. So I need to break it up into 4 groups. So that's Q3 minus Q1. So I'm going to break each of these up into more groups, and 35 divided by 2 is 17.5, which is not a whole number of human beings, but we can do our best estimate. So 17.5, 17.5, and 17.5. So here's what I'm going to do. I'm going to go, the Q1 is going to be the number that's in between these two. This number in here was the median, or I should put MED for median, and this is the Q3 value. Okay, so we need to go find that on our graph. So like 17.5, I'm going to round that to the 18th person. We're going to try to approximate based on knowing the 18th person. So that's somewhere in here, and that goes right down to, I don't know, it looks like it's a little bit to the right to me. So guys, again, it's an approximation, okay? But I'm going to go with 33 for Q1. And then we also need the Q3 value, so I need to figure out what person is that. Well, right here we have 17.5, and we have it 3 times. So I'm looking at 52.5, the 52.5th person. So I'm going to go to 53. So 53 are my best guess on 53. I'm going to trace that over. That hits right in here. Trace that down, and I'm at like, it's just a little bit to the right of 55, so maybe I'll go with 56. So 56 minus 33 is 23. That's my estimation of the interquartile range. How many spent more than 80 minutes? Let's see. Let's take a look. We have the cumulative frequency here. We have how much they scored right here. Minutes. We actually can't answer that. So guys, that's a trick question. We don't know anything about the number of minutes. It says nothing about that. And then we're asked to produce a box and whisker plot of the data. Okay, let's try it. So we'll figure out what we think our minimum value is, what we think our maximum value is. And I'm actually just going to take this exact labeling right here. So we're going to go 0 to 80, and then I'll fill in other stuff as we need. So 80, 0, maybe 40's in the middle. And so let's go through and figure out what all these values need to be. Well, we already know that the maximum score is 80, and someone achieved that. So I'm going to put that mark on here. And we know the quartile 3 score, although, yes, sorry, that's my bad penmanship. That's a 5. So sorry about that. Some of you are probably cringing as I wrote that earlier. Okay, so we already know the quartile 3 value is at 56, so I just need to get that onto here. So I'll make that 60, and we'll make that 20, so 56 is somewhere in here. And then we need the median. The median we had at 43, so that's right in here. And then we had the quartile 1, which is at 33, so that's probably about here. And then the minimum, guys, this one's tricky. We don't exactly know the minimum, but because we don't have a perfect representation, we have to make a guess. I'm going to guess at 0 because I don't really know. Okay, so this is the one that has quite a bit of uncertainty to it. So remember, you got the median here. In the middle we have a box, so I'm going to draw my box. Put a line down through the median. Draw your whiskers out. There's a little whisker, there's a little whisker, and now we have whiskers. And that's it. That's our box and whisker plot. That's going to be all for today's video. Hope you enjoyed it, and I'll see you next time.